Hello, welcome to this session. Uh, Welcome to this. I mean, myself, Shantanu Chakraborty. I'm an assistant professor in the Department of Data Science, Techno India University. Today, I'll be sharing my view on introduction to programming in Python. So let us start with what is Python. As we know, Python is a programming language which is widely used in for various applications. So it's basically the programming is something where we write an algorithm or we write programs in order to get a solution to a problem. So Python is one of the most extensively used programming languages that we use. But basically, we should know what is a program, what is an algorithm, and what is and how it works. So let us first define what is a compiler. So a compiler is a translator that converts the source code to an object code, where the object code is in the machine level language and the source code is in a high level programming language. So compiler is basically one of the high level programming languages that we use. So it translates the source code to the target code. So that is what the compiler does. Interpreter is another translator program. So what the interpreter does, it reads line by line and it converts the source code to an object code. The interpreter that translates the human readable form, that is the source code, to machine understandable form. So what it does, it converts the human source code to the object code. So that is what the Python is using. Python is using interpreter. It translates the source code to an object code. Then we come into what is a debugger. So a debugger is basically that allows the programmer to run program and see which source code line is currently being executed. So that is what is the role of a debugger. So the values of the variable and other program elements can be used in debuggers. And debuggers are very important for locating errors that are known in any programming language. So when you write a program, so it's very imperative that you get an error, and you need to track those errors and you need to rectify those errors so that you can run your program without any error. So here lies the role of a debugger. So debugger will allow the programmer to simultaneously run a program and see whether the source code line is being currently executed or not. So if there is any error in the program, so the debugger will prompt and it will allow us to remove those errors. Then comes a profiler. So a profiler is used to evaluate the program performance. So when we use a profiler, we try to evaluate the performance of a program. It indicates how many times a portion of a program is executed. So that is how we use a profiler. And during a particular run, the profiler will be used to ensure that all code in a program are being used somewhere during the testing. So it's also known as a coverage. So profiling is basically to find out the parts of the programs that can be improved to make the program run faster. So it also increases the performance and the efficiency of the program, because if you're able to profile the parts by which you can optimize or you can reduce your execution time or your response time, so that also has a very direct impact on the performance of the program. So profiler is used to evaluate the program's performance, and it indicates how many portion of the program that can be executed during a particular execution and what can be done so that we can optimize the source code. So that is what is the job role of a profiler, right? Then comes the flow control. So there is a program counter which points to a particular location in the memory, and it computation starts by execution the instruction at a time. So basically the flow control mechanism in some program where you jump to some memory location and you try to execute the program instruction, and this is called as a flow control. So it helps us to write programs that can perform a very complex task. So this is very, very important that we know how is the flow control mechanism playing a very important role in programming language. So flow control is also very important because we have lot of looping and branching statements that we use in Python programming language. which allows the programmer to know where to jump to the next program instruction and which particular program instruction will be the next in the sequence to be executed. So this will help us to write the program that can perform the complex task. So the program can be properly identified, they can be properly allow us to know the execution sequence, which instruction will be executed first and which instruction will be executed second and which instruction will be executed third. So this is very, very important that we know the flow, we know the control of a program, how it has to be executed and how it has to meet all the criteria. Then comes the syntax. So it defines which string basically and the character and the symbol which gives a meaningful output. So we use various keywords. So the keywords can be in a programming language, can be a variable, it can be a string, it can be a character basically, or it can be your identifiers, that is the name of a variable or a function that you provide. So there are various keywords that we are using. The keywords are those words that has got a predefined meaning. So when you are doing a programming, so you have some set of words which has got a predefined meaning, and these words that has got a predefined meaning are called as keywords. The string is something that you write in double quotes. So anything that you write in double quotes, triple quotes, single quotes in Python is treated as a string. So string plays a very, very important role. So this is how we define and declare a string in a Python programming language. Then there is very syntax and semantics that we need to follow. So there has to be a well-defined syntax and semantics that we are supposed to follow when we are writing a program statement. So if something is not as per the syntax or the semantics that is provided, then the compiler or the interpreter basically will provide you an error. And that is what you need to rectify or correct. So it's very, very important that you know that your program provides us with the proper syntax or semantics that we are using. So the proper syntax should be the one, for example, if your indent is not properly matching, or if you have not provided a colon at the end of the if statement, or you have not properly terminated a statement, or a bracket is missing. So these are the some of the very genuine syntax error that we generally get into when we are executing the program. So we should be very careful that the syntax should be properly provided and the string should be properly terminated. The syntax is properly acceptable, and this particular syntax and semantics has to be specified explicitly. So it becomes very, very important that the programming that we do should have proper syntax and semantics. Now we come down to Python programming language. So who invented Python programming language and when it was invented? So Python is a high-level programming language, and it is invented by the scientist Guido von Rossum. So Guido von Rossum is the one who invented the Python programming language, and it was first started in 1989, but the official release was in the year 1991. So Guido von Rossum, who invented Python, he was very much inspired from the Monty's Python Flying Circus, which was a BBC comedy series from the year 1970s. So as he was a very big fan for Monty Flying Circus, which is a series in BBC comedy series, so he named his programming language as Python. So Guido von Rossum is the one who invented Python programming language. Then comes very important is your features and characteristics features of Python. It's very, very important when we go into programming, we know what are the characteristics features of Python programming language. So these are some of the characteristics features of Python programming language, which makes it very unique. And which makes it very, very important for all the stakeholders. Number one, Python is open source and it is free. So it's freely downloadable from any open access source. So since it is free and it is openly accessed from anywhere, so it's basically you don't have to purchase a Python programming language from a vendor as it comes free of cost. So this is what makes Python programming language a very, very important tool. Number two, it is highly portable and basically the one, it can be programmed on Windows and it can run on Mac or Linux. So it's very portable. It's not basically based on certain uh, platform. Basically, Python can work in Windows platform, it can work in Linux platform, it can work in the MacBook platform. Python is an interpreted language. At a runtime, it interprets line by line and it executes those particular line. And Python is also a high-level programming language. Basically, the instructions given in the Python language are in English language. So it's a high-level programming language. It is easy for the user to understand Python programming, but we convert the source code to an object code in a Python programming language. So this is basically is one of the high-level programming language. It is used for general purpose programming language. That means it can be used for any type of specific domain application or web applications, basically. And it's very easy as compared to C++ or Java. Basically, when we compare C++ or when we use the Java, we see that there are a lot of syntax and semantics that one need to understand and one need to remember in those type of programming language. But when it comes to Python, it's very, very user friendly and it basically gives lot of operators data type for the user to use it and to configure it. And it provides some very easy syntax and semantics so that it becomes easy for the programmer to write the program, execute the code. And the sample size of the code in the Python is half or one third of the size of the code that you write in Java or any other programming language. So it's very extensible. Basically, it supports lot and lot of libraries, and it is basically easy to combine the pieces of the programming language C, C++. So Python is object-oriented programming language. It's very user-friendly and it provides us with a lot of operators and data types that becomes very helpful to the user to write and decode and run the program very easily. Then comes the reason for selection of the Python programming language. So there are various reasons why you should select a Python programming language. The reason that you should select a Python programming language is basically it has a great community support, very easy to understand. It's extremely user friendly as compared to Java or any other programming language. And there's no need to declare a variable data type as we do in C and C++, if you remember, that we need to define a variable before we use that variable in our program. But Python is absolutely user friendly and you don't have to basically define a variable or a data type of a variable before using it in a program. So, and it is very expressive programming language. You can write a lot of things in a few lines, a few set of codes. So that what makes Python very useful. So what we have learned, let us summarize our discussion. We learned about what do you mean by various algorithm and algorithm flowcharts, very important for programming. We learned what is a compiler. We learned what is a compiler. It's basically a translator that converts your source code to an object code. And we also discussed about interpreter, which converts line by line from the source code to an object code. We found out what's the role of debugger and profiler in programming and the flow control mechanism, which instructions to be executed one after another, and what will be the flow of the execution of these instructions that you referred. We also define the semantic error. We also define what you mean by high-level programming language and what are the features of Python programming language, which makes it very, very user-friendly and it makes it very, very unique across any particular platform. So this is how we know about Python programming language, and we know how Python can be used for so versatile and so portable that it can be used in any particular platform. These are some of the references that you all can use for introduction to the Python programming, which will be very helpful. we need to understand what's basically an editor and how the editor allows the programmer to enter the source code and save it in a file. So most programming editor increase the productivity of programming, right? So there are various program editors that are provided. So Python has IDE. IDE stands for Integrated Development Environment. So what is an IDE? It's basically a software that consolidates some basic tools that is required to write and test a software. So various software developers, they use various tools for coding and testing. So Python, we use Anaconda Navigator, we use Spider, we use these tools for the writing the program, for debugging and for coding and for testing. We use Spider or we use Jupyter, we use various online Python environments such as Google Colab, where we can write and code and test the code. So there are various development tools that we often include, which includes text editor, code libraries, compiler, and test platform. So this is all the IDE or the integrated development environment that we must select, deploy, integrate, and manage these tools separately. So what is the benefit of using IDE in Python? So there are various benefits that one can derive for using IDE or the integrated development environment in Python. Number one, it will provide the development and the testing tool in a one integrated development environment. It standardizes the development process by organizing the necessary features which are required for software development. And the requirement for a good programming language and coding environment, that it plays a very important role because we can run the code from within the environment. We can use different debugging tools. We can use the syntax highlighter and automatic code formatting. So these are some good coding environment which is provided where we can save and reload the code files. We can debug it. We can highlight the syntax. We can automate the code formatting and other things. Now, for Python, you can use PyCharm. It comes with the professional and it is an open space community edition, and it's available for Mac, Book, Windows, and for Linux platform where you can run, you can edit, and you can debug a Python code. It can be a slow but it provides us a various settings where we can run the code and we can execute the code and we can check the output, right? Then we have Spider. Spider is basically the scientific Python development environment. So in the Python Spider, what we use, it is an open source cross platform, which is used for data science. It integrates the essential libraries in data science such as NumPy, SciPy, Matplotlib. So this is what is being integrated into Spider, which is a scientific Python development environment. Then we have a Jupyter notebook. A Jupyter notebook denotes the document that contains both the code and with a rich text element. It has got figures, it has got various links and equations. So the Jupyter is basically related to Python and R, and it supports open source web application that allows us to create, share the document and provides live code, equations, and visualization and narrative. So this is all are the part and parcel of our Jupyter notebook. Then comes Anaconda. So Anaconda is basically a open source distribution of the Python and R. Basically, it's a bundle of Python packages that are commonly used by the people using Python for scientific computing. So we use Anaconda, which is a part of IDE, that is the integrated development environment, where you can provide a single download and install the program that install all the packages in the one go. So this is how Anaconda work, which is an open source distribution of the Python and R. Then comes Jupyter Notebook. So Jupyter Notebook is a client server application that allows to edit and run the notebook via a web browser. So when we are running a web book or a notebook via web server, that comes through Jupyter Notebook. So the kernel is a program that runs and that introspect the user code. The Jupyter app has a kernel for the Python coding. So that's very, very important. The kernel part of a Jupyter notebook and a dashboard of an application that not only shows the notebook document, but it can reopen and it can be used to manage this kernel that can shut down, which is running, right? So these are the few screenshots how you go about the installation of Python. Basically, the Anaconda Navigator or the Jupyter Notebook or the Spider that you get under part of your integrated development environment in Python. So this is the first step that we'll go about with. We visit the Anaconda and we download the web page from the link anaconda.com, and the page will look something like that. Now, after the Anaconda installation, you'll select the operating system for where you're installing, whether you're installing for 64-bit or 32-bit, and what type of interface that you're using. Are you using Windows? Are you using Mac? Or you using Linux? So you can specify and you can select the operating system. So once that is selected, then you can go to downloads and you can download the Anaconda Navigator based on the operating system that you have selected, which is very, very important. Where you download the correct version of the Python that you're using. Basically, we go for the latest version of the Python when we are going to install it on our device, right? Now we open and run the installer. So once you have completed the download, you'll see Anaconda 5 point or 7 point or 6 point version.exe file. And once you click on open, and that execution file will start the installer, and the installer will try to install the Anaconda Navigator package. Then it welcomes to the Anaconda 64-bit setup, which will guide you through the installation of the Anaconda. And it's recommended that you use Anaconda latest version and you run this installation. So once you click on next and agree, then you get the license agreement. And once you click on the license agreement, your Anaconda will provide you the path environment variable where you can register and you start your installation. So you select the installation type, and installation type is for 64-bit setup, where you like to perform Anaconda 64-bit, and this is how your installation starts. So once your installation has started, then you go to choose the installation location where you want to install. You can browse and you can select the drive or the folder where you wish to install your Anaconda Navigator or the software that you downloaded. Now, once the installation starts, you customize your installation and you can register Anaconda as your default Python version, and then you click on installation. So it'll take quite a lot of time, around 5 to 10 minutes to install the Python package on your device for 64-bit or 32-bit machine or configuration, that whatever you're using. It can install in Windows, it can install in MacBook, it can install in Linux. Then once you have installed, you'll get this dialog box that opens up. Thanks for installing Anaconda 3. And Anaconda is basically the most popular Python data science platform that we use nowadays, right? And once you have installation is through and you go to the start menu, you'll get the Anaconda prompt. After select the install complete, you can go to the Anaconda startup menu and select the Anaconda prompt. So once this prompt is started, you'll be getting the Python distribution in Anaconda prompt in the command box like this. Now this is the Python version. You see something like this, and you can type the Python command and you can import this on your device, right? So this is how it looks like from the command prompt. The Python interpreter, it looks like this. Then you have the Anaconda Navigator. So once you go to the Anaconda Navigator, what you see, you'll be seeing this Anaconda Navigator setup, which will have the Jupyter Notebook, and it will also have the other installation tools such as the Spider, which you can select and you can configure your device accordingly. So once that is done, then you can go to the upper right corner through your navigator, and your notebook will be used as a new tab in your web browser. And then you can browse your tab and you can install your tab in case of Anaconda Navigator. And this is the notebook and this is the editor that you can see through and where you can write, you can run, you can debug, your code, and you can check for the latest outputs and the updates. So this is the Anaconda prompt that we get. We get the Anaconda Navigator and other tools in Python programming language. So this is the Anaconda video that you should look, which looks something like that. And you can see the editor where you can copy, paste, and browse once you entered the command for the first time. This is the Anaconda prompt video that should look something like that in your Python notebook, the one that you're using. And then comes your web browser, Jupyter. So Jupyter is basically a web browser that you enable you to browse through various, through in a web browser, you write Jupyter Notebook or the local host. So you can browse the Jupyter file on your web browser. It can be your Google Chrome, or it can be Internet Explorer. So here you can open the local host and you can browse your Python file. You can open it, you can run it, you can debug it on Jupyter Notebook. So this is how is the interface of the Jupyter Notebook that looks like in your Python IDE 3, that is Integrated Development Environment. And once that is done, you get a notebook where you can write, and you can write your code, and you can execute the code on a Jupyter Notebook. And you can debug, you can run, and you can watch the output also. So today, what we have learned is what do you mean by integrated development environment? What is the best integrated development environment that is used for Python? How to install and configure Python on your device? The Jupyter Notebook from your web browser, and how the debugging and bugging can be done. So this is all for the today's. These are a few references that you can refer. Thank you. That's all for that. Going to explore something about the concept of modules and packages in Python. So what are the various modules and packages that we can use in the Python, which makes it very useful for the programmers. So the namespace is a very important thing in the Python and in the other programming language, where we can provide some extra features, and names can be given to various things like function. For example, this is a name given to a function which can be referred in your program code. So name can be used. Everything in Python is an object, such as number, string, function, etc. And the objects can be accessed through their names directly or indirectly. Now, there are various rules for naming. Number one, names must either start with a letter, or it must start with an underscore. So name must start either a letter or an underscore. Python reserved keyword cannot be used. So what are the keywords? As I've already told you, the keywords are those words that has got a predefined meaning. So names are basically case sensitive, and we can have uppercase and lowercase. So Python has got reserved keyword, and that cannot be used as a variable, right? So that's a very important part in a Python programming language. Now, Python module is basically the source file which consists of the statement, and it consists of various modules. We can import a module name. We can use a namespace in our module, where we simply write the Python code that needs to be executed, and we interpret and we treat it as a module which gets into its own namespace. So this is very important about the modules that we use in Python, right? And the import statement that we use, a Python code containing the import, and it should be the one that we use for the keyword and the name of the module that we provide, right? So writing a module. So this is how we write a module, how we create a module. This is a module for addition or subtraction of two numbers. So what is a module that we are writing for addition and subtraction of the two numbers? So we create a file and we save it as with .py extension. So these are the modules that we use for addition of two numbers, subtraction of two numbers, and you import the module calculation. So once you've created a module calculation, and you just can directly use the methods that you have defined and declared in this module into your program. and that creates another Python script for the same directory. So basically, we can import the calculation module by writing import calculation. And under the calculation module, we got the method addition and subtraction, and we can access those method on addition and subtraction that is already defined within the calculation module. So this is how we write a module. We write a module for addition, we write a module for subtraction, and then we import that module, and then we can use the method defined in that particular module, right? So from module name, we can import some name. So basically, some name is basically we can import a few separated by commas. So here, there's no need to prefix a module name. Just the name directly can help us. Is really helpful to see what is the code that we're using within the given module. So this is how we add a module, and we import that module, and we try to use the methods that are defined within a given module. So modules can be called and imported, and this is the best practices that we use to load a module and to define the methods that we are provided within the given module and import that module into the Python namespace. So when the calculating module is imported, the interpreter search for a built-in module with its name, and then it search for the path and the installation file, then it starts the installation accordingly, one after another. So we import sys, that is a particular module. Basically, add under that, we can append the path, and we can import another module, and we can use the method defined within that module. So this is how Python is extremely flexible, as it provides us with various modules and the way we can use that module for our use, right? So then we come down to byte compiled files. Very, very important how we get a byte compiled file in a Python. So we import a module which increases the execution time of a program, and it speed up the process to create a byte compiled file with the extension .pyc. So basically, the Python converts the source code to intermediate code, that is a byte code, and then it converts the byte code into an object code. So as we use JVM in the Java virtual machine, we use PVM, Python virtual machine. So here, module increases the execution time of a program, and to speed up that, we create PYC file, that is the byte compiled file, and which is very useful when the same module is imported over and over of time in different programs, and will make the program execution much more faster and platform independent. So these are some of the flexibility that we use for Python programming language. Now we use dir function. So dir function is used to find out all the names that is defined within a given module. So suppose if you have defined various names within a given module, if you use the dir function will give you all the name that contained within the module. The attribute should begin with underscore underscore name. That is a default Python attribute associated with a module. And then comes the scope. So scope refer to the particular part of a program from where the namespace you're trying to access with without a prefix. So scopes are important for the isolation they provide within the module. So scope of the function that you're using, the scope of the module that you're using, the scope of the program and the built-in functions that you're using, playing a very, very important and vital role in your Python programming language. There are certain global keywords which can be prefixed with Python to use in that particular module. And then comes the packages that allows for a hierarchical structuring of a module. So namespace using the dot notation, package aligns for the hierarchical structuring. So the module helps avoid collision between the global variables, and packages helps avoid collision between the module name. So we can use package that allows for hierarchical structuring. So creating a package is quite straightforward, and it it makes use of the operating system hierarchical file structure that we are using. So that is how we create a package, and we use the hierarchical structuring of the module and the namespace using the dot notation. It's quite the same way we use the module to help and avoid the collision between the global variables and the local variables. So I hope it's clear from the today what exactly is the module, right?